Hey everyone, today we are having one more real interesting problem, which is to find out the lowest common ancestor of a binary tree. So basically, in this question, you are given two nodes, and you need to find out which node is the lowest common ancestor of these two given nodes. So first of all, I would like to clarify what is LCA or what is lowest common ancestor. So by following the definition for any two nodes, okay, let's say x and y, okay, for any two nodes in the given binary tree, any two nodes, whatever you can take, okay, the lowest common ancestor, let's take it as z, is the nearest node in the binary tree that has both x and y as its descendant. So what exactly I am explaining is, let's say two nodes like 4 and 5, okay. So if I take 4 and 5 in this example, so what, which all nodes are its common ancestor? First of all, let's understand what common ancestor is, okay. Then we can make some distinction between these two guys. I mean, what is common ancestor and what is lowest common ancestor? These two are entirely different, you know characters, entirely different, character playing in this particular question. Okay, so what is common ancestor? Let's, as you had taken 4 and 5 into consideration, so one of the common ancestor is 2 and other one is 1. You know what is ancestor? Ancestor means the grandparent. Like 4 and 5 is the children of 1, okay. Similarly, we can say 4 and 5 are the children of 2. So 2 is one common ancestor, so is 1. So but which one is the lowest? Or lowest means nearest, okay. Here lowest means nearest. So which one is the nearest common ancestor? So 2 is the nearest common ancestor, so we can say 2 is the lowest common ancestor, isn't it? I hope you got it. If you did not get it, then please leave a comment below, so that I can give you more hints about it, so that it will be more helpful to you, for understanding purposes. Anyway, let's take one exam. Okay, let's. Okay, I think you got it, and let's quickly fill this out. I just read just ready this questionnaire for you for the better understanding purposes. It will cover many cases, okay. It will just help you to understand what exactly it is. So if I take 4 and 6 into consideration, okay, so what all the common ancestor are there present for these two guys? So can I say 2 is the common ancestor for 4 and 6? No, I cannot say, because 2 of course 2 is the parent of 4, but not parent or anything, any relation with like 6, okay. He is not the ancestor of 6. It is you can see it, right? But I can say 1 is the common ancestor of both 4 and 6, because from 1 we have several edges, outgoing edges to both of the two nodes, okay. So what is the lowest common ancestor of these two guys then? So the 1 is the both common ancestor as well as lowest common ancestor, because this is the only node which is present for these two guys, okay. So in this case we can say 1. So what about 4 and 5? So as we already talk about it, so this is 2, okay. So what about 4 and 1? Let's say 4 and 1. See, it's interesting. If I talk about 4 and 1, so I can think of 4, but what about 1? Because 1 doesn't have any parent, isn't it? Because it's already the parent node of this binary tree. That is why a statement is given in this question that where we allow a node to be a descendant of itself. Okay, let's say we are given two nodes P and Q, and there we can say that the node can be the descendant of itself. So one can be the descendant of itself. That is why we can say that one is one is the child of one. So anyway, so in this example also, we can see that one is responsible, responsible, ancestor. Okay, because the outgoing edges, actually, coming from one, reaching all the way to four. That is why the both common ancestor and lowest common ancestor is one for this example, 4 and 1. Okay, if I say the P is 5 and Q is 3, 5 and 3. Okay, in this example also we can clearly see that one is the both common and lowest common ancestor. Okay, I hope you got the thing, and I hope that you got the distinction, the difference between common ancestor and lowest common ancestor. So without any further ado, let's quickly jump into the conceptual diagram where we will actually implement, where we will actually think, how to proceed, how to proceed to solve this particular problem. Okay, how should we think to solve this particular problem? So uh, let me bring a pen so that I can draw, and I can show you that how can we think of it. Now in this example, let's take any two node. Okay, for just the testing purposes, let's say we took what to let's say 8 and 5. Okay, this particular and this particular node. Okay, so now let's try to look over the ways we can think of. Okay, let's start moving. First of all, I would like you to just think on in this way, that let's start moving from the root to these two nodes. Okay, then let's see what happens. Let me change the color of my pen so that I can show you what is happening right here. Yeah, so let's quickly just move the or just to follow the path from root node to that particular node. Let's quickly just follow. So green color basically, this is green, and green color basically showing that I am going to 8. Okay, so this is the path for 8. Cool. Similarly, let's choose some another color which will define the path for reaching 5. Okay, see, I am actually drawing the same path for reaching 5 until 2, you know uh, uh, actually till 2, and to move 5, actually I turned, okay, some other direction. So wait, uh, let's think about it a bit. Okay, before proceeding further, as you can see, when we are moving towards 5, okay, it the path gets changed, the it gets changed the way we followed the path for reaching 8, isn't it? And the turning point is also 2. So we can say 2 is the lowest common ancestor of both 8 and 5, isn't it? Yes, we can say. Similarly, you can verify for others. Okay, you can take any two node and just find out which one is the node, which is behaving as the turning point of both of the given nodes. Okay, so what exactly we did to find out the LCA? Okay, one sec. Actually, I want to ask you that did you actually understand that why we say that 2 is the common ancestor? Because this is the node which is basically responsible, which is taking the responsibility of the turning part. I mean, okay, when I move from when I step out from right here, I mean from the root node to reach both of these two nodes, when I reach 2, till now it is okay because I am following a you know a, a common path. Okay, but from 2 I am actually taking the let's say two guys are just walking from 1 to reach both 8 and 5, which are two destinations for these two guys, but they are actually turning from 2, take turns from 2. I hope you are getting. So if they are, getting, different, if they are going in different direction, that means this is the guy, this is the point, which is the lowest common ancestor, because this is the point which is nearest to nearest from these two, given nodes, isn't it? Yeah. So this is it. So let me tell you that how what we exactly did to find out this LCA. Basically, we followed the path or way to reach both of them, and when we find the turning point for both of them, we stopped there and we declared that this particular node, is the LCA, is the required answer. Okay, so yeah, so I hope you got it. So let's start. Yeah. So let's actually let me actually erase it. Okay. So for now, uh, let me actually write down the path as well, so that you can uh, you know visualize better clearly. So let's follow the path for reaching to 8. So actually, let me write the nodes here. Node 1 is 8, and node 2 is 5. Okay, so path 1, which is to reach 5, is 1, then 2, then okay, let's make it array. 1, then 2, then 4, then 8. Okay, similarly path 2 array is 1, then 2, then 5. Okay, so what we all see right here is, see, when we started moving from 1, so these two value will be definitely going to same, because we are starting from 1. When we are right here in 2, till then everything is okay, but after 2, see, we are actually these two guys are actually taking two different ways. Okay, to reach both 8 and 5. So we can say, so basically, whenever we find two different values in two arrays, so we will stop there and we will say that look back. Okay, just look back and see what the element was before, just before reaching here. So if we just look back from 4, we see that this is 2. So 2 is the lowest common ancestor, and we just need to return it. I hope you got it. I hope you got the point. So here we will simply return, uh, let's say we have reached this particular point, let's call it point pnt. Okay, so we can return it from any particular array, both path 1 and path 2, because the point, the moment they choose different ways before before from beginning to that particular point everything was same. So we can return from any of this array, let's say path 2, and let's call it pnt, where the mismatch happen -1. Okay, so this will be our complete solution, this will be our answer. So I hope you got it, got the solution. So I will quickly write the code, and if you have any doubt in the code point of view, then you can simply just comment me. Okay, and I will surely get back to you on your doubt, so that so that your learning thing goes smoothly. Okay, so basically here I have given, sorry, we have the root node and two different nodes. Okay, given nodes. So basically what can we think, like, if there is no root, this is our base condition, this is our this is a S cases. Okay, then we should return none, just telling that okay, I have received an empty array, or empty, sorry, I have received an empty binary tree, so there is no such ancestor, something like that. I am just storing the nodes in the array, and I will call the array path 1 and path 2, and I will simply just call just finding out the path to reach both of the points. Okay, I will say I'll just pass this and path 1 right here. Similar case for finding out the path for Q. And after finding it, let's say we defined P and T, where the mismatch will going to happen. Let's say P and T is from 0 to P and T less than, we can say whichever the minimum whichever the minimum size, we should move till that. Let's say why I'm saying minimum, because let's say one node is given as 2 and the other one is like 9 or something, again some way down to here. Okay, so the array for the path for 2 is similar, simple, the of size of 2. But what about this particular node, which is present a way down right here, or somewhere like that? So that is can be bigger. So we do not need to take need the after all this. Okay, whenever the mismatch happen, I need to just take care of this particular path. Okay, I do not need all this element right after present in the big array. I think you are getting. Okay, so let me say that path 1 dot size, and after this I can say pnt plus plus. Okay, and here I will just I will just what we'll do is I will just find out the mismatch. Okay, if the mismatch happen in any point, if the mismatch happens to in any point. Okay, one thing to take care of is this path vector or path array doesn't contain the value, rather it contains the node. That is why we need to compare the value. Okay, cool. So in that case, what will we do is we will simply break out of the loop, and I will simply going to return any of one. I mean, let's say path 2, or here we can say path 1 or something like that. We will just return pnt minus 1. So that's it. So now just quickly fill this thing, and it will again going to be void because we do not need to. Okay, one sec. Is the is we need to, we need also to take care of a fact that whether these two nodes exist in this binary tree or not. So all the nodes have unique value. P and Q are different, and both values will exist in the binary tree. That is why we can say just find out the path. We do not need to take care of whether it is existing or not. Otherwise, we need to just take boolean type just to return whether it is true, whether it can be found or not. All this. Okay. So what it takes is root, and let's say key. Okay, and okay, sorry, that's the path. All right, is it? Yeah. So what if I hit a node which is empty, I mean which is null? So I should return out of it. Clear? And here I should push the element to my list just to test it. Okay. And if I let's say uh, I am finding the path for 7. So I reach here at 6, and there is no way to reach 7 from 6. So what will I do? I will simply pop this element from my array and go back to 2 and go back to 7 in this way. So that what am I actually doing? I am actually just trying to backtrack all these things. Okay. So root value, and here if I actually encounter that I have reached my destination, we'll simply return. No need to go further and just keep myself messed up in the recursive call. Okay, I need to call for both of the sides to find out the thing. I mean find out the path basically, both side. Okay, and after it, what I will do, I wait we can, what will I do? I need the complete path, isn't it? Let's say I am at 7. So it will, what it will do, it will come to 3, then 5, then 6, then nothing. Then it will just cut it, then move to 2. Okay, then move to 7. It got it. Okay, it will just insert it, and again when returning from here, it will just cut it, isn't it? So in this case, I need to tell him that if the last element of this array, I can use the path dot back. This will tell me the what is the last element. This this is a function, inbuilt function for factor. You can check it out. So if the value of last element is not equal to key, okay, then only you need to pop, otherwise you do not need to. Okay, cool. Then I will simply return like a good boy. Yeah, so basically this is it. So let's test it whether it is working or not. Okay, there is some error. is the issue? It should be there, isn't it? What is the issue? If back value is uh, okay. I'm sorry. It should be trade node star. Okay, just to get the actual thing, isn't it? Okay, there is one more thing. Okay, I am here again. See, but this is one mistake. I'm sorry. I'm actually taking the node, but I was actually inserting the value. That's my fault, clearly. So it says that is accepted. Now just submit it to see whether it is working or not, and it worked. So yeah, this is the solution, and I hope you enjoyed throughout the session. And so please subscribe the channel. You know, the hit the like button, and please support this channel. And just just tell me which particular question you did last time, which which you liked very much. And yeah, that's all. Hope you doing well. So just enjoy doing everything which you know want to do, and everything which you wanted to do as well. Okay, so thanks.